Good afternoon. This is the Complex Workshop on Green Infrastructure and Innovative Approaches for Alternative Stormwater Management. We're going to get started in just a minute. Thank you. Good afternoon, and thank you for joining the Southeast Florida Regional Climate Change Compact's workshop focused on green infrastructure and innovative approaches for alternative stormwater management. My name is Lauren Evans, and I am a staff consultant to the Southeast Florida Regional Climate Change Compact. Since the compact's inception in 2009, it is focused on aligning local government action to build resilience to climate change and reduce greenhouse gas emissions across the four-county region of Broward, Miami-Dade, Monroe, and Palm Beach counties. The compact has successfully built bipartisan commitment to break down the silos across local governments to assess our shared vulnerabilities to climate impacts and has developed the Regional Climate Action Plan with specific recommendations for climate action and has made significant implementation progress on these recommendations. This workshop series aims to provide local practitioners a deeper understanding of the recommendations of the Climate Action Plan. Please advance the slide. One more. Thank you. Our workshop will support several of the RCAP's recommendations, including to advance the use of nature-based solutions, develop and use maintainable green infrastructure for water supply, stormwater, and wastewater management, incorporate green infrastructure and transportation policy and project design, utilize technical workshops to develop adaptation strategies, including those focused on living with water that include case studies of green and gray solutions, and coordinate the implementation of innovative water management technologies and methodologies across our jurisdictions, sharing information about the results, costs, and savings of such technologies. Next slide. So it's certainly not news to this audience that we have some really unique stormwater challenges in Southeast Florida. Drainage systems in the region are driven by unique topographic and hydrographic conditions. Our extremely low topographic gradient and relatively pervious soils require that stormwater management systems rely heavily on natural underground storage rather than using conventional conveyance structures and large outfalls. Rising seas will continue to increase groundwater levels, reducing available soil storage and increasing inundation from precipitation events. Moreover, rising seas may also reduce the capacity of coastal water control structures to discharge inland waters to tidal areas, thereby increasing surface water stage and nearby groundwater levels. It's been estimated that sea level rise of roughly 9 inches above 2010 levels would reduce the overall capacity of the flood control structures in Southeast Florida by up to 70%. Stormwater infrastructure must now do more than simply convey runoff. It must also provide expanded storage, reduce flood risk, and improve water quality while supporting critical environmental and public health outcomes. It's imperative that our adaptation strategies recover lost storage capacity through integrating and scaling green infrastructure, enhancing system flexibility, and advancing innovative approaches and technologies for alternative stormwater management. Today's workshop will explore some of these solutions, both nature-based and engineered, that have already been deployed throughout the region and beyond. Next slide. So let's dive into our agenda. We're going to begin by grounding in the state of the science as it relates to green infrastructure solutions for stormwater management, where we're also going to hear more about the co-benefits, ROI, and temporal considerations in green infrastructure planning. We're then going to hear about legislation that was passed this session on coastal resilience, excuse me, Senate Bill 302. We're going to learn about what this means for planning in Southeast Florida and the importance of the upcoming rulemaking process. We will then spend the remainder of the workshop focused on case study presentations from the region, as well as one great example from Martin County that has applicability within the four-county region. We'll learn about the innovative drainage design at Port Everglades, a 19-acre reclaimed golf course turned multi-use park with stormwater retention features on Miami Beach. a living streetscape that stores water in Coral Gables. And finally, we'll end up in Martin County learning about a neighborhood project that integrates distributed green stormwater infrastructure. Our case study speakers bridge multiple sectors and areas of expertise from transportation to community development, capital improvements, engineering, public works, landscape architecture, and resilience, truly demonstrating that the key to operationalizing and scaling these solutions requires integration across the whole of government. Finally, a few housekeeping notes before I turn it over to our first speaker. This webinar is being recorded. We're going to post the recording and all the presentations on the Compact's website after the workshop. Please use the Q&A function at the bottom of your screen to ask a question at any point during the speaker's presentation. We will have Q&A after each presentation, and we will try to get to as many questions as possible. We encourage you sharing as many questions as you have. A link to the agenda is provided here in the chat for your reference. So with that, I'd like to introduce our first speaker, Dr. Tiffany Troxler. Tiffany is an associate professor in the Department of Earth and Environment and director of science at Florida International University, and is also the director of their Sea Level Solutions Center. FIU and Tiffany in particular have provided just incredible support to the Compact over the years, and we are incredibly fortunate to have Tiffany's expertise here in our region. Thank you very much, Tiffany.
Ready to take it away?
Yes, please.
Okay, great. Thank you so much. It's a pleasure to be here to kick off this exciting workshop. So yeah, thank you so much, Lauren. And let's get started. So given the multitude of stressors and shocks we're grappling with here in urban environments in South Florida, we need to seek ways to improve the overall value and return on investment of our urban environment. And our urban management strategies. And stormwater infrastructure is no different. We have to design our systems to do more than simply convey runoff, as Lauren was mentioning. We need to seek ways in which we can increase storage, reduce flood risk, improve water quality, while also providing multiple co-benefits within our environment and for public health. In other words, our green stormwater infrastructure, we need to move toward more multifunctional green infrastructure. Next, please. And one way we can visualize this concept of multifunctional stormwater infrastructure is with this simple diagram. So on the left, I'm showing an image of gray infrastructure and the number of dimensions in terms of the potential benefits that infrastructure can produce. And on the right, I'm showing an example from a green infrastructure feature. And so great infrastructure does allow us to regulate water flow, but we can be a little more creative utilizing alternative approaches to regulating water flow and also produce co-benefits of water quality regulation, heat regulation, improve and promote the potential for carbon storage, improve the regulation of pollutants in the atmosphere, increase habitat and biodiversity, increase the aesthetics of the urban environment and the public realm, and also improve educational value. Next, please. And so what is green infrastructure? So just a quick backdrop here in case you've not become familiar with the term, but essentially we're talking about infrastructure that uses plant soils and other media to capture and treat stormwater at its source. And it relies on the natural processes of filtration, infiltration, and evapotranspiration to manage stormwater. And it can be integrated at multiple scales, integrated at the site level and interconnected or repeated over multiple areas within a neighborhood, can convey and promote neighborhood scale benefits, and then over multiple neighborhoods can promote benefits at the regional scale. Next, please. And so it bears reiterating that by by integrating those features at us across sites, we can achieve larger scale benefits. And in particular, as part of a decentralized management strategy, we can create maximize benefits through approaches. For example, people refer to treatment trains as a way to improve the volume reduction as well as improve water quality benefits, and utilizing different types of features within on sites and across neighborhoods can create more comprehensive benefits. Next, please. And to speak on the economic benefits, so this is a study that was released in 2023 for the DC metropolitan region. And that assessment reported multiple economic benefits, including 91 million in average annual economic output, $45 million in labor income, 60 million value added, and over 430 jobs either created or supported. Next, please. Yeah, just continue to click through those. And so we can think about green infrastructure features as organized along an ecological to technological spectrum, with some features like open space preservation being more natural features to permeable pavements and cisterns that are among the more engineered features. And green stormwater infrastructure sits along the spectrum at the interface between natural and more engineered, including detention basins, wet retention basins, constructed wetlands, bioretention, including curbside bioswales, and green roofs and permeable pavements with urban trees. Next, please. Yeah, keep going. Thanks. And the design determines the potential benefits. For instance, green stormwater infrastructure that integrates features of street trees, engineered stormwater controls, and green roofs would provide the most comprehensive multifunctional set of potential benefits in our urban inland environments. And this is from a 2019 paper on the sociological and technological factors that moderate the value of green infrastructure in urban environments. Next, please. But what does the science say, indicate about the performance of green stormwater infrastructure? Next, please. So let's take an example from a synthesis largely developed from data reported in the Best Management Practices database. This is a little data report now, but instructive nonetheless, where here we see on the left percent volume reduction, in the middle figure percent nitrogen reduction, and to the right, the figure on the top right, percent sediment, suspended sediment reduction for a suite of different green stormwater infrastructure types. And what you might notice immediately is a lot of variability within these green stormwater infrastructure features for these different performance values or these performance elements. And so while the synthesis shows a significant, for example, percent volume reduction for a few of these features, and the means there are those yellow dots. And we still see quite a bit of variability across these feature types in terms of their function. And so what that calls for is a need for more local, site-specific, and long-term monitoring of green stormwater infrastructure to improve the resolution of their performance and co-benefits. And I'll share a few examples with you now. Next, please. So this is a study that was conducted by Dr. Jasmine Locke, a recent PhD graduate at FIU, and she focused on what's called floating treatment wetlands. And these are artificial ecosystems designed to mimic the nutrient removal of natural wetlands through hydroponic cultivation of plants on floating rafts. And you see Jasmine there up at the top right, standing on one of these floating rafts, probably in Pinecrest there. Um, but she also looked at the potential commercial viability of producing cut flowers from these floating wetland treatment mats. And so the study aimed to assess the growth and success of nutrient remediation capacities of 5 cut flower species in controlled mesocosms. Next, please. And so here I'm showing 2 graphs. On the top right is accumulated phosphorus mass removed, and on the bottom left, or sorry, the bottom right, accumulated nitrogen mass removed. And in the red, that's the accumulated mass removed, and in blue, that is the water quality data from the control mesocosm. And so what she found is that comparing different types of cut flowers, marigolds are performing quite well. And they're in this particular study showed that the marigolds removed 52% more phosphorus and 33% more nitrogen compared to controls. And then also was assessed the cost recovery, so the commercial viability, where costs for supplies can be recovered over 1.5 harvests, and also a means of incentivizing that continued biomass removal associated with the floating wetland mats. Next, please. And another study, this was released in 2021. This one's based in Philadelphia, and this is looking at an urban infiltration trench system. And I'm showing it here because of the methodology that is quite transferable and can be applied for any study looking at the performance of urban infiltration trench systems. And these are popular in dense urban areas because of the small footprint they potentially can occupy. And the modeling that's typically used to assess the performance of these, sometimes using the EPA stormwater management model, is typically based on event-based modeling, which can lead to a more conservative design for green stormwater infrastructure. And we know that they behave dynamically over seasons and under variable rainfall conditions. And this particular study aimed to develop continuous simulation models and compare that or calibrate that and validate that with observational data. Next, please. And so 3 years of observations illustrated seasonality in these green stormwater infrastructure features, where they found higher recession rates in warmer months and lower recession rates in colder months, and a head dependency where higher recession rates were found when water levels were higher. And applying those observational data, those authors developed monthly adjustment factors, which better capture the dynamic performance of this particular green stormwater infrastructure feature. And I'm showing that on the top right, where with the observations compared to the dynamic model with the adjustment features for seasonality and head dependency, and as compared with the static application of the SWIM model. And that study showed good correspondence with the number and duration of overflow events within that infiltration trench, and illustrating that illustrating a methodology that can be extended to other generalized sets of monthly adjustment factors for different conditions or different infiltration trench systems, and the value of those observational data. Next, please. And this is a deployment of a monitoring system that's been established on FIU's campus for green stormwater infrastructure, including one of these infiltration exfiltration trenches, generating observational data that can improve the the performance of those models when we're estimating their performance of those systems. Next, please. And then this study was released in 2025. This took a water balance approach to estimate the performance of a constructed stormwater wetland. And this is another Pennsylvania example on the Villanova campus. And here they retrofitted a retention basin to create a constructed stormwater wetland and evaluated the performance of that coastal of that constructed stormwater wetland for managing inflows. Next, please. And in this case, there were a number of interesting results from this study, but one that was of particular interest is something they described as an effective imperviousness reversal, where by changing the land type from that retention basin to a constructed stormwater wetland, they illustrated that the relationship between rainfall and outflow was similar as if the receiving watershed, the imperviousness had been reduced by 15%. So by including that constructed wetland, changing that land type from a retention basin, they were able to reduce the effective imperviousness of that watershed. Next, please. And then just to note that Dr. Ibrahimian has also established a constructed wetland green stormwater infrastructure monitoring site on FIU's campus where similar processes can be explored. Next, please. And just one last project. So this one's what I mentioned are site-specific, site-based green stormwater infrastructure strategies. This one is looking at a regional scale. And here, the project's funded by the National Fish and Wildlife Foundation with a number of collaborative partners. And here we're co-developing with stakeholders feasible and desirable flood protection alternatives based on implementation of different types and configurations of green infrastructure features, and evaluating the influence on watershed scale flooding, economic benefits, pollutant load reduction, and Biscayne Bay wildlife benefits. And the modeling scenarios will be evaluating different design storms and sea level rise scenarios, and ultimately producing a coastal watershed resilience implementation plan for the C7 or the Little River Basin, with the purpose of helping to support new funding applications for project implementation. Next, please. And finally, I'd just like to make a quick pitch for opportunities that are available at most universities with landscape architecture programs. Students are required for their degrees to enroll in urban design studios and produce projects. And faculty are always keen to collaborate with local stakeholders to develop real-world design plans that can support stakeholder initiatives. So it's a great opportunity to envision new alternative approaches to stormwater management strategies that are more transformative, and also give these students an opportunity to work on real-world plans and projects. Next, please. Yeah, so that concludes my presentation. If you have any questions, be happy to take those, or if you have any perspectives on these discussion questions, would love to hear them. Thank you so much.
Thank you so much, Tiffany. We do have a few questions coming in. The first one is for porous pavement. Do you find that there's significant investment that needs to be made in the maintenance to ensure continued functionality? I'm not sure if this is an area you have expertise, but if you do, I'd love your thoughts.
Yeah, I mean that it's really important. I didn't get a chance to touch on maintenance, but it absolutely needs to be incorporated as part of the management of green stormwater infrastructure. Yeah, absolutely.
Another question, could you please share some specific examples of how green infrastructure increases economic activity as cited in the study of GSI in the DC region?
Yeah, so In part, it is related to jobs that are produced for those landscape architects that we mentioned. Also, from a technical perspective, in uh, in uh, what was just mentioned about pervious pavement. So, maintenance of these systems is really important, and that is one source of creating new opportunities for jobs.
Excellent. And the final question we have here is, oops, one more just came in, so we'll see if we can get to that one. Could you elaborate on elaborate on the quote, how does function vary by GSI form slide? In particular, this person is asking about the impact of retention ponds on volumetric reduction. I don't know if you want to go back to that slide.
Certainly
Russell
could.
is let's see.
Yeah, I think the point there is there's a lot of variability in it, and it depends. There's going to be some site context. So within those ranges, there's quite a bit of variability in terms of volumetric uh, reduction.
Yeah.
Yeah.
Thank you. Final question, and we are going to hear from City of Miami Beach on this project directly, but this question is about, are you seeing more parks like Bayshore Park being retrofitted for resilience? Are you sort of seeing an uptick in this functionality?
I'm seeing an uptick in the interest from residents to see this happening.
And interestingly, it's the question is from Susie Bailey with a Residence for Resilience. So
Okay, yeah.
that's a perfect, yeah, perfect comment.
But fortunately, we do have a really nice example that you hear about today. Yeah. Thank
Yeah,
you.
great. All right, wonderful, Tiffany. Well, thank you so much for your presentation and all of your work in this space. Next, we are going to move on to a presentation by Janet Bowman, who is a senior policy advisor with a specific focus on climate policy for the Nature Conservancy in Florida. Janet and I've been fortunate enough to work alongside Janet for many years, and we worked together at the Nature Conservancy for many years. She's been a personal mentor of mine. I know a few people more thoughtful about state climate and environmental policy than Janet, so we are just so pleased to have you, Janet. Thank you so much for sharing your expertise today.
Thank you. Thank you so much, Lauren. So I'm going to take you all on a sort of short tour of what I would call one of the successes of the last legislative session, and that's the passage of Senate Bill 302, Coastal Resiliency. Um, One of the things I know the compact and many local governments in the Southeast Florida region and other regions of Florida have have addressed in terms of implementing nature-based solutions are really kind of the top two are funding and permitting. And, the funding issue was certainly addressed by the legislature with the Resilient Florida program. But the permitting issue has really remained kind of a bugaboo in terms of it sometimes causing delays, posing impediments to implementing nature-based solutions, really in spite of, I think, what is general acceptance in Florida, both at the state and local level, of the value of these kinds of projects. Next slide. Okay, so just a very brief overview. This was the third or fourth year that this bill was taken up, and it's never quite reached the finish line until this year. It was sponsored by Senator Garcia and Representative Mooney, and as well as a number of co-sponsors. It was one of the first bills signed by the governor in March, so shortly after session was over. And the effective date of the bills, July 1st, so that's coming up. And as you see, it's actually the first chapter law of this session, Chapter 2026-1, Laws of Florida. Next slide. So the bill really addresses kind of two key components. One is developing design standards and permitting standards for nature-based solutions, which we'll go into depth on that. But the other is addressing how permitting is conducted in aquatic preserves, which is another big piece of the puzzle in implementing nature-based solutions around Florida. So in terms of permitting, the bill directs DEP to do two things. One, to develop some specific design guidelines and standards by January 1st of 2027 for optimal combinations of nature-based methods for using green or hybrid green-gray infrastructure to address coastal resiliency. So that's, I would think of it as a sort of a design guidebook for those types of projects. And then the second and more difficult is requiring DEP to initiate rulemaking by January 1st, 2027. And the legislature decided to retain the right to ratify the rulemaking that DEP comes up with. And what that means is DEP will go through the rulemaking process, develop a rule, but before the rule can become effective, it has to be approved by the Florida legislature. Next slide. So getting into the permitting process criteria, the legislature enumerated a number of key criteria and processes they want addressed in the permitting package. They want, the typical criteria and thresholds for permits, including monitoring, inspection, and reporting, procedures for application review, um, provisions for emergencies, abandonment and removal of systems when deemed appropriate, addressing significant erosion in areas of critical concern, addressing exemptions and general permits that are crafted in a way that they do not allow for adverse impacts. And I would just say, to date, on the permitting front, the Army Corps of Engineers and DEP have a general permit for living shorelines, but it's very limited. DEP's been working on expanding that a bit, but I would say the statute invites them to go beyond what they were contemplating in that rulemaking activity. It asked DEP in the rules to address coastal resiliency, including use of some alternative kinds of solutions, including living seawalls, shoreline and vegetation planning, seagrass planning, wave attenuation devices, highlighted green or hybrid green-gray stormwater infrastructure, which we're talking about today. And I think that's important because the permitting to date has really been fairly focused on living shorelines. Beach renourishment, dune and wetland restoration, reinforced dunes, reef restoration, and developing ecologically sound building materials. Next slide. And then also one key provision of the permitting criteria is DEP specifically directed to create permitting incentives for use of new technologies, including 3D printing, which you all are familiar with in Dade County, Miami-Dade County. And then one aspect that's been something that I've really have thought needed addressing, and that's how to permit nature-based solutions following storm events to replace failed coastal infrastructure with nature-based or green-gray hybrid infrastructure. And I think you can look to the Tampa Bay area, Southwest Florida, following, Ian and Milton and Helene to see the struggle it has been for folks whose seawalls were damaged or destroyed to think about using nature-based solution alternatives because of the difficulty in permitting. Typically, after a disaster, DEP will issue an emergency order allowing homeowners to rebuild failed seawalls in the same configuration as they were before. But if you want to deviate from that, it's a more difficult road. So this should help address that situation. They want the rules to be sure to protect and maintain access to navigation and to identify ways local governments can participate in coastal resiliency. Next slide. Okay, then the second major part of the bill deals with aquatic preserves. And the aquatic preserve rules were developed many, many years ago to primarily protect against the illegal dredging and filling that was happening along Florida's coast. And so some heightened permitting criteria to protect coastal resources in the preserves was adopted in the statute, with the Board of Trustees maintaining authority as the Board of Trustees of the Internal Improvement Trust Fund. So while these rules are very protective, they have made it difficult to innovate in terms of building certain gray green infrastructures and also using fill for purposes of mangrove restoration, for example. So this particular provision amends 258.42 to provide an exemption from the prohibition of certain structures within an aquatic preserve for nature-based solutions to improve coastal resiliency. And it specifically refers to living seawalls, shoreline, and vegetation. Next slide. And then in South Florida, the Biscayne Bay Aquatic Preserve is an important aquatic preserve where many of the compact local governments have been involved in projects that involve permitting both under state rules and specific aquatic preserve rules for Biscayne Bay that are very protective in terms of not harming seagrass, not filling, etc. So this provision allows minimum dredging and filling for restoration activities and enhancement of natural systems, including substrate for vegetation planting and restoration for mangroves, salt marshes, seagrasses, and oyster reefs for coastal resiliency purposes. Next slide. And then finally, in the Tampa Bay area, the Terracea Aquatic Preserve was called out and some provisions specific to it were adopted. And during the legislative session, a proposal came to light where a cruise ship developer wanted to build a major cruise port kind of in the area of the Sunshine Skyway, which is adjacent to Terracea Aquatic Preserve. And because of concerns about the potential impacts of that kind of development on the preserve, this legislation was included in this already filed bill. And it would prohibit dredging and filling of the submerged lands of the aquatic preserve, except under certain circumstances. And minimum dredging is authorized for public navigation or for a public necessity, placement of riprap or other alteration that's necessary to enhance the quality and utility of the preserve. Dredging and filling is maybe necessary for the purposes of eliminating hazardous conditions and for the creation of marinas, boat ramps, piers, and docks, etc. And then one of the probably more important provisions is it reiterates that the Board of Trustees must publicly notice any authorization of use in the aquatic preserve of alteration, dredging, and filling, etc. Next slide. So implementation. this is where you all come in. DEP, the Resilient Florida program, in my understanding, is sort of taking the lead in developing the standards and the permitting processes. The standards are supposed to be adopted or completed by January 1st, 2027. The rulemaking process has to begin by January 1st, 2027. So this is your opportunity to weigh in on what these permit standards and processes should look like. DEP, to their credit, really runs a very open rulemaking process. So if you all are interested in participating, by all means do so. The permitting rule will require legislative ratification, and sometimes that can take more than one session. So that's another sort of entree into advocating for the rule and changes. And then the aquatic preserve dredge and fill criteria will be implemented by statute through DEP's permitting process.
Thank you, Janet. We have a few questions. Will the legislative ratification of the permitting process mean, in your view, that it will be easily influenced by political winds?
Well, my answer is it creates that opportunity. However, I would say that it's important in this case for the user community that, that are trying to implement these solutions to help develop a good rule. That's really important. And then this kind of permitting, particularly since there's a Resilient Florida program, I see it as less subject to that kind of influence than just say the stormwater rule that was I think the last major rule that was ratified. This is less fundamentally regulatory. It's not integral to every major development in Florida in comparison to the stormwater rule, which is. So I think there's a chance that this could go through fairly cleanly.
On the topic of development, what is your perspective on how this bill interacts with whether it precludes potentially the proposed port expansion projects?
Um, no, I don't think it precludes the port expansion projects.
Okay. Another question just came through. Does the new Terracea rule provide more opportunity for development / marinas than was previously allowed in the aquatic preserve? So similar question.
Well, I think that's an open question. The intent behind that language was to prevent this mega development, but the language is such that it does seem to open up well, it certainly allows permitting of individual docks and limited marinas, that sort of thing. So I think there is a question of how protective it is. And then one thing about the public notice piece of it that I would highlight is back in the day, the governor and cabinet, when they would act on proposals, controversial permits or consents of use or grants of lease in aquatic preserves, I mean, busloads of people would potentially come to Tallahassee and testify, for something, some big controversial project. And the cabinet process has really, over the years, been restructured where it really kind of shuts out that kind of grassroots input. So, I just point that out that I find it less transparent than it used to be.
One final question. This one's question from me. What opportunities do you see via the rulemaking process to ensure that this is as positive and effective as possible in supporting green infrastructure in a sensible way? What would you say are the best methods for local governments to engage here?
Well, I think the best methods are they'll have probably rule-making workshops is to participate in those workshops. I know many of the local governments that are on the webinar participated in the rule adoption for Resilient Florida. I found in that process they were pretty responsive to those comments. So I would participate in that way and keep on top of DEP. And again, they are generally, compared to some other state agencies, I find them to be very responsive to comments.
Great. Well, thank you, Janet. Really appreciate this information. It's so important for all of us to stay engaged in these processes. So thanks for your time. I'd now like to turn it over to Nirmal Datta, Capital Program Administrator, and Richard Tornese, Director, both within the Highway Construction and Engineering Division of Broward County. Richard and Nirmal will provide us with an overview of Broward County's innovative approach to stormwater retention in the commercial and heavy use context at Port Everglades. So appreciate you both being here. Thank you.
Yeah, thank you for inviting us, and actually enjoyed Janet's presentation too. It's in line with what we're going to be presenting here in some ways. We want to highlight one of our green infrastructure projects that we think it's an innovative approach. It's something that that we needed as part of the project, but we felt that this was a great way to basically treat discharge, flooding, any kind of issues with drainage runoff, and try to keep, preserve the environment in a way where we're not harming things in and around it, because we're in the port. So this project is going to be in the port. And this my background here. I have a background in transportation, of course, but for the most part, too, I have drainage background that actually helps me in my job as far as some of these type of projects that we try to think out of the box.
Richard, excuse me 1 second. I want to make sure. Can you see Russell's slides?
Can we
Yes, we can see your slides. Yeah.
Yeah,
You
now
can-
we can see it. Yeah,
you
sorry,
can see
we
this stuff?
have double screen, so so now we're concentrated on the one screen. Yeah, so now we're back on. Yeah, I had to switch the monitors around. So
No, I just wanted to make sure that everybody was able to see the slides. Okay, thank you very much. Continue.
yeah, no, even for ourselves. So now we're on the right slide, which is my background. So so as I said, my background is in transportation, of course, with leading highway construction. Hopefully, that's a good thing to have. But really, I have drainage background also, and try to think out of the box and a lot of projects that we have, just not to just put a gray infrastructure in everywhere. So that's my background. And next slide, please.
Yeah, I've been working with Broward County for the last 12 years. I have 30 years of experience. A lot of bigger projects ranging from $5 million to $51 million. Next slide, please. We're going to talk about the projects.
Yeah, here we go. So this project here, and I'll go through the slide itself, but I just want to give you a little bit of introduction, is that we had a project that came about that's right at the port, right at Port Everglades. And of course, the environment around it, you definitely don't want to do anything to disturb that, and especially being to get to coastal air. And also, too, as we're doing work, and anything we dig up with fuel in an area, and it's environmental issues, definitely concerning, at least in the port area. So we had a project which we completed most of the project already, and a part of the project was establishing this one marshaling yard, which we're going to go through as part of a project that that we needed to do, is to make sure that we could build our project. So we're going to show it, and Normal was the engineer of record on it, so he was responsible for the design, and it's constructed and it's successful. So that's why we're showing it. But it's a successful project, so we definitely want to let everyone know doing something a little different can work. So we're going to present the traditional gray storm. We're going to review gray stormwater design versus green. I don't think it's much of a choice. I think green is way to go, at least if you have a choice, right? Sometimes gray, I think, is if you don't have the room or you don't have the ability to do it, you have to do that, and there's really not much options. But if there's a way to incorporate green infrastructure, we try to, and we think this was a good project to show how we could. We use this true grid system for stormwater infrastructure. It's a new system. Normal was the one that actually researched it and figured out a way of actually accomplishing what we need as part of the project, but still have this green infrastructure in place. Next slide, please. So, you can read this later, but the gray infrastructure, we know it's, curb and gutter, piping. We have pavement everywhere. More or less, it's just runoff is definitely an issue, and especially when you have impervious around an area where it's environmentally sensitive, right around the port. So we don't want to have impervious areas. We want to preserve the pervious areas if it's functioning okay, or if it's not functioning okay, let's improve it. So, but that was the key point as part of our stormwater review for this project, is try to keep as much green infrastructure in place and still deal with the runoff that we'll have from the roadways. Next slide, please. So of course, a big benefit is reducing localized flooding for, and that was where this project will highlight. When Normal goes through it, you'll see where we had this flooding in and around this area, and it was consistent. It was quite a bit that they couldn't use the area for a long period of time. The water was discharge. I mean, runoff wasn't going anywhere, and it was becoming an issue for mosquitoes, for other things that are really, we don't really want to have it. And definitely the flooding and runoff went beyond that area into where it went into drainage systems that of course went out to the intercoastal, which is an issue too. So the issue with the green infrastructure, we think it actually is a big benefit for the community. So, well, it's the port, but we still think if you use this type of design somewhere else other than, let's say, a port area, the community, I think, will benefit from it, and we think it's visually much better too. Next slide, please. Okay, so we were, considering, let's say, EPA and everything that we need to do as far as treating discharge and everything else. We understand that we do as much as we can. We sometimes use exfiltration trench underground. Even when we're doing like replacing roadways and parking lots, we try to do some kind of system where where we don't have the room to put the green infrastructure, so we put it underground. But it doesn't work as well. It's hard to maintain, and so we think that that doing something on the surface, whether it's a retention area, dry retention area, a wet retention area, or something like we're going to show you here, which actually is a little bit of an innovative approach to a parking, using parking where you can have vehicles park and still have stable ground. We'll show that there is a way of doing it and still have some kind of green infrastructure in place and accommodate heavy vehicles. Next slide, please. Okay, so now I'm going to let Nirmal go through the actual project itself, and then he can walk you through his thoughts of how he treated the runoff that would be necessary from the roadway if we actually paved this area.
So thank you, Richard. Thank you, everybody, for joining us. As you can see, the screen on the right side has a Disney cruise, and our project is Eisenhower and Southeast 20 southwest corner of the Southeast 20th Street and Eisenhower Boulevard, as you can see, within the Port Everglades and within the city of Fort Lauderdale. Next slide, please. So this is a schematic drawing without any cross section or anything, just showing that how the site is being accessed for the event type. So this is a schematic plans. Next slide, please. So how this project is created and objective. So But there are a couple of objectives that we had in mind because we are creating a convention center expansion. We are doing Omni Hotel, and we had a bypass road contractor. So we had to create a parking facility that can hold every one of them. And this is a temporary parking facility. And then our project size is about 11 acres. So we were creating 920 new passenger car parking facility. Sometimes they put big trucks, but the parking facility can accommodate those. And then how this project was evolved, and the Broward County Convention Center has expanded over 1.2 million square feet event spaces and a 29-story, 101-room Omni Hotel building. So to meet the parking need, marshalling year project has been created. So project concept and final design, everything done through in-house design team, Broward County in-house design team. And then construction was done by True Grid pavers and weekly asphalt together. And then CI team was F&G engineering group. Next slide, please. So if you can see the pictures, this was the scenario when before we went into the site. There was a lot of water ponding. Mosquito was an event issue. So nobody was, if there is any big rain event, it was full of water. So the project site was not being utilized before perfectly. Next slide, please. So this is the construction ongoing process. We were showing some of the True Grid. We'll show you some pictures of detail, and then some of the cross sections. But this showing the ongoing process construction. Next slide, please. So this is True Grid sample on the right side, Richard, if you want to.
Okay. Yeah, I mean, this is actually what the True Grid looks like without actually the aggregate inside the cylinders there. That's the reinforcement. So there's not only we have a base, and we're going to go through the cross section that shows how you would construct something like this, but that distributes the load, the wheel loads that you would actually have on top of basically gravel. But in order to reinforce the gravel and actually not have the gravel actually shift, the cylinders are in place, along with providing structural integrity as far as the overall loads that are be exerted on the grid itself. Next slide, please.
Yeah. So this is a cross sections from their website. It shows how True Grid actually work when you have a rain event. It can go through the system, and then it can percolate inside or sideway. That's
it's non-pervious. So if you look to the left, you see the pervious soil and non-pervious. Which what happens is it actually acts like almost like a drainage pipe in a way. So if it's you won't see it on the surface. So it could be ponding underneath in certain areas because it's just not getting the the perk rate that you need. But it is definitely used. They can use the area still, and it won't be flooded or to a point where you can't have any vehicles in there. They would just get stuck. Next slide.
Yeah, so this is the cross sections. So where it shows that True Grid pavers is about 1.5 inches or 1 to 2 inches, and then underneath we have 8 inches, 6 to 8 inches of gravel, and then the bottom is just soil reinforcement.
Yeah, and then one thing, lessons learned. So one, I'm going to give you a lessons learned because we actually had to go back out there and do something a little different. So you see the 8-inch gravel is like 3/4 inch, like wash rock. It's angular rock and stone, which is great. It's great for percolation and everything else. And then on top of that is the grid, and then in the grid you have the smaller aggregate, and it's like 5/8 or maybe or 3/4 that you can use in those cylinders. We found that because you're gonna have people walking on top of the grid, and smoothness of basically having smaller aggregate. It's much easier for ADA compliance. It's much easier for tripping hazards because then you can slightly cover the grid in order so it's not exposing the actual cylinders itself. So it even for long-term maintenance. So we had to come back in there and add finer aggregate on top just to make sure we can have that walkable surface. Next slide, please. Well, oh, we have the video. Yes.
Yeah, you can. If you can click on the go down. No, same slides. Hold the mouse in there. No. So on the same slides, click on the pictures. And the
I don't
bottom.
think, Nirmal, I'm sorry, I don't think the video functionality is working within the
Okay, all right.
Yeah, we can share from.
No, that's okay. So we can explain that more or less the runoff and everything. You can see the grid there. You actually can see the grid on this where it's not flush, right? So we found that even though that's what the design from the manufacturer thought it would be best, we actually came back over there with finer aggregate, still getting good perk out of the actual parking area, but make it where it's much more of like a small aggregate you would see in any parking area that you want to accommodate people that walking at least high heels or just no tripping hazards as we because some of these, if it's they could be a tripping hazard if it's not maintained properly. Next slide, please.
Yeah, so Richard already mentioned some of the challenges that we had. We had a vegetation growth over time. So somebody needs to maintain this, and therefore ADA compatibility, we had to add finer aggregate. And sometimes heavier equipment in the middle can damage the true grid cell. So we learned our lesson. We had to replace few cells. This is designed to do track load and regular car. But if the construction equipment, like a 5-ton loader and things like that, it can damage the cell.
Yeah, next slide, please.
Next slide. So the design cost was nothing because it's done by in-house group. And then total construction cost for this whole area was about $4 million. And then ongoing operation and maintenance cost was $50,000 per year around. And then the metrics of success, the historical flooding or water ponding was eliminated. And then one of the key components that we had is the hotel building and then convention center expansion, giving us very tight a schedule that we had to build something within a year. And they give us also 4 million. They say, this is your budget, this is your time, build it. So that's why we had to find this innovative solution, which works for everything, Next slide, please. So these are some of the other projects. It's showing how true grid pavers can be used in different other projects. And this has been used, this is one of them used in Orlando.
Next slide, please.
Next slide. This is another one used in Hallandale Beach for using true grids. Next slide, please. Okay, this is Q&A. I wish we could have shown the video.
Yeah.
Sorry about that. It didn't actually populate in the deck. If you want to pull it up, we can try to show it real quick. I don't know if that is an easy thing to pull up or not.
You want to try to pull it up here?
Yeah.
Yeah. You can see it on the other screen. Yeah.
In the interim, let me get started and just asking you a question or two. So we do have a few. Does your team know if True Grid contributes to soil compaction in the long term that may reduce its efficacy?
Well, it's not going to. It actually just acts as a reinforcement. It's almost like if you look at let's say you have a concrete slab and you have reinforcing steel in there, and then the steel distributes a lot of the load. It's similar to that. So it really doesn't contribute to any kind of compaction. at all. It really what it does is distributes the load and also keeps the aggregate. We're out for maintenance, everything. So it's like those cylinders are filled and they're instead of it spreading everywhere and it'd be a nightmare to come back and forth and regrade it all the time. But it's mostly just for distribute load. We have similar products that we use for soil reinforcement, and it's very similar.
Um, let's see. Was this placed on native soil or on compacted road base?
This was like a half and half. Like we have silos before in that particular location. So half of the area was compacted and then half of them were not.
Yeah, it was like a tank farm for fuel. And
Okay.
so it ended up, and that was the other thing. We don't want to dig in there, putting basically drainage pipe or anything like that. So it's an environmentally sensitive area in a way. When we start disturbing it, it becomes an issue. So we just built on more or less on top, and just built it up so we had a pervious layer.
Great. Um, when was this project put into place, and can you talk a little bit about the impact it has had in reducing or eliminating localized flooding? Do you have a sense? I know you showed the slide that was from the manufacturer on sort of the retention rate, but do you have a sense at this project site kind of how much stormwater the system has been able to retain versus traditional pavement?
So this one, about 10-year, 1 day storm can hold on these particular things. And the project was completed about 6 months.
No, about a year and a half ago. As far as the marshalling yard.
Yeah.
It's been over. Yeah, it's been over about a year and a half total. Um, and we've gone through some heavy storm events. Actually, it hasn't flooded yet to a point where it was never usable. It was very rare we even see any surface water at all. It's working so good that we're actually expanding it. We have another project that we're doing in that same area. They like it. It's working well, so they want to expand the parking.
Excellent. I'm sorry, go ahead.
The project was created in a slope, in a direction.
Yeah, we sloping it. We actually, yeah, that's a good point. We did slope it towards the west, where then we had a retention area. So it ended up like it would almost act as like a drainage pipe in a way under the ground, where it just percolates all the way to and carries because it's going to eventually get to that impervious area that, of course, was holding water to begin with. It eventually gets to a point where it gets into the retention area. So, but it makes that whole area at least usable.
Final question. We have a question about maintenance, just hearing kind of feedback that this sort of permeable parking lot can be difficult to maintain. Curious about your experience there. I know this project hasn't been in service all of that long, but what are your thoughts on maintenance? And also, is that a barrier, or are there other major barriers you see to expanding the use of this type of material, both within county transportation projects as well as private sector projects across the region?
Well, really, this project itself, the maintenance part of it has been maintenance free in a way. I don't think we've only gone out there to maintain a few areas when they had heavy equipment that was actually offloading pipe in that area, and with a pitchfork basically lifted up the actual grid itself. So other than more or less damaging it, not purposely but carelessly, really we haven't had to do anything since it's been in place. Like I said, we did put these finer aggregate on top because we think it's a better product for people walking on there and ADA. And the barriers. Some of the permitting agencies give you credit for some of this, and some don't. And since this is a temporary parking area at this point, we were able to build it, but we think there should be more leniency in the permitting agencies to allow for more of these type of innovative green solutions. And get credit for it, because then the designers will be more apt to propose it.
And that for the maintenance, we put like around 50,000 for total 11-acre lot. Right? It's just to spray in case any weeds comes up.
Unless
it's
any
a minimum.
Yeah.
It's not like any major cost, right? Like you can think of.
Well, I really applaud Broward's innovation here and willingness to try something very different. So I certainly hope to see more of these sorts of projects popping up across our region, and hopefully this will serve as a great case study example. So thank you both so much, Richard and Amal. I appreciate your time.
Oh, no, thank you. Thanks for inviting us. We appreciate
Thank
it.
you. We were going to take a quick break, but we are running a little bit behind. So I'm going to just move us straight through the break. I'm sure you guys will appreciate being done with this workshop when we said we were going to be rather than breaking. So with that, I'd like to welcome our next two presenters who are going to share on the City of Miami Beach's recently opened Bayshore Park project. To provide this overview, we're going to hear from David Gomez, the Director of the Office of Capital Improvements from the City of Miami Beach, and Amy Knowles, who is their Chief Resilience Officer and Director of Environment and Sustainability. They both really supported throughout this project and bringing this project to completion. So thank you so much, Amy and David. Take it away.
Great. Well, thank you so much, Lauren. It's just a pleasure to be here today and to introduce David Gomez as well. He's our wonderful CIP director, and I definitely twisted his arm to do this today, but he's got a tremendous story to tell. We're very proud of this project. As I've said, a lot of the pictures that I've seen throughout this afternoon have actually been of Bayshore Park. It has been a project in the making, and just would encourage all the other practitioners out there to stick with it. This has been, I think, about 14 to 16 years of a project, so it can be done. Next slide. We're going to talk a little bit about this, of course, this project, the very significant blue-green infrastructure piece that it represents for the City of Miami Beach. We are only 7 square miles. We are a very dense coastal island, so we don't have acres and acres of space. It's definitely an example of living with water, and something that really came out of our Urban Land Institute Advisory Services panel. We'll highlight some of the areas of innovation. Of course, we'll talk about the retention lake and all of the other sustainability and resilience pieces. We'll talk about our funding sources, we'll talk about constraints, and we'll talk about our permitting and partnerships, and lots of, challenges and lessons learned as well. Next slide. So Bayshore Park is located in the middle of the City of Miami Beach. It's about 19 acres. It was formerly a golf course years and years ago. It's located at 2530 Pine Tree Drive. It was opened about 6 to 9 months ago, and it was a beautiful opening event. And the whole goal was to create a passive park of natural beauty for community enjoyment and enrichment, and also reflecting our island's culture and ecology, and servicing as a model of sustainability, stewardship, and resilience. You can see here, it's right next to our high school. You can see the football field. It is near the Scott Rakow a youth center, and it's in the middle of a beautiful walkable neighborhood. So a little bit about the history. The golf course itself, next slide, was actually built in 1915. It was a full golf course. Over time, it was changed, and the land was used for different purposes, and eventually a smaller golf course was there, and it stopped being used. It was a very passive area, and there was a lot of plans to recreate another golf course. And that plan was actually canceled. It was revised, rescoped, a lot of, as I've heard it, engagement from the community and lots of thoughts of what to do. It was even used as a construction debris site after Hurricane Irma back in 2018. So the original design to go back to a golf course was actually scrapped. The City Commission had a lot of leadership, and I'm told with staff as well. And there was a new concept actually planned by the planning team, or actually internal department, who created this concept of a passive park with the stormwater retention, really making sure that it could, be this area people could visit, enjoy. There's tons of trees, make it walkable, and also create lots of uses like tennis courts and golf park, dog parks as well. And so the City Commission gave some direction. There had to be some engineering done to see if it could really serve as a stormwater retention area. A lot of evaluation done to see how the gravity flow could work, how the pump and pipe discharge could work. Could we actually do this on-site storage, considering this is a contaminated site? And then we wanted to integrate as much solar power, permeable paving, recycled materials as well. So there was a lot of buy-in. However, there were funding shortfalls. These projects get more and more expensive. And this project was able to be included in a general obligation bond that was done in 2018 as part of an overall $439 million bond for the city. So that did require resident support, and it had overwhelming support as well. And now I'll turn it over to David to talk a little bit about issues and constraints.
We can go to the next slide. And just expanding on what Amy was saying, I think it's important to note that this park received new life during a commission meeting. It was a meeting to award the construction contract for a par 3 golf course where the mayor and commissioners decided we don't really need another golf course and scrapped the award. A little shocking to all of us that were expecting to start a construction project, but it turned it around and we began anew a design for a more resilient facility. A little bit of context on the park, as Amy mentioned, it's in essentially the center of the city in a residential neighborhood. It's bounded on 3 sides by single-family homes. On the northeast corner, there is a community center, a city community center. To the south is one of the city's high schools, or the city's high school, as well as the public works facility. Before we started, the site itself contained a local stormwater pump station. Really nothing to speak of in terms of identity or place or conditions. It was just a large green field monoculture that we used as a debris waste site during or after hurricanes. We can go to the next slide. So the task for us was to make this an example of what we could do with blue-green infrastructure and how we could turn what was essentially a vacant lot, uncharacteristic lot, into something special. And you'll see in a little bit exactly how we did that. But the truth is we focused on, number one, the design storm, 25-year, 3-day storm event, incorporation of permeable surfaces almost everywhere, including the Coquino walkways, the paver parking lot, and many of the other areas of the park that were permeable. As Amy mentioned, we included solar panels. In the retention pond, we included an ozone treatment and circulation system. Similar to some of the stuff we saw earlier today, we used a lot of a system called an R tank, which is essentially underground retention area that allows percolation over time. We looked at increasing tree canopy and lowering the heat island effect. And of course, focusing on all landscaping being Florida native plants. We can go to the next slide. So some of the things we incorporated, probably the key feature is the retention lake with the ozone system. I mentioned the R tanks, and that in and of itself avoids any offsite drainage or discharge into the canal. It's actually a little tricky because the intent or the first task of the park was to help the neighborhood with some of its storm drainage challenges. So this is a very low-lying area of the city, and the streets often flood. So we were looking at a way that we could use the park as ideally a park, but also when needed to help reduce some of the flooding experienced by the neighborhood. That's where the retention lake came in. Unfortunately, this was or is a contaminated site. So we had to look at ways to manage the known contaminants. We did that through soil encapsulation. The slide says creation of a sunset hill. I find that name a little annoying, but we'll use it. Really, it's talking about how we moved soil within the park property. Some of it had to be removed and taken off site for treatment and disposal. Obviously, I'm sure you all know that that process is not only cumbersome, but very expensive. So we looked at how we could keep some of those soils on site through encapsulation, meaning that we looked at grading, we looked at how we brought in clean fill to encapsulate the contaminants below, and then of course through very careful treat relocations and transplanting, we were able to save a lot of the trees on site, starting primarily with just preservation of existing trees. We can go to the next slide. I mentioned before, permeable pavers and surfaces were very important to us. The perimeter walkway is a crushed coquina pathway that's designed to be permeable. And then, of course, it mentions the pavers and the ozone treatment. Next slide, please. Florida native plants, very important to us. The lake itself was probably a little more complicated than the rest of the park, only because we were creating a new habitat around the lake with its littoral zones and water tolerant plants. Because this lake will eventually be connected to neighborhood drainage, the level in the water levels in the lake will fluctuate over time. So we needed to make sure that the plants around the lake would be sustainable. Next slide, please. Funding in the park, this is almost a $43 million park. It was not cheap. And of course, the key with any project like this is being able to find the champions, the supporters that are going to help you get to the finish line. In this case, primarily, it was our residents. They elected to vote for the GEO bond that helped fund this project. And then, of course, our elected officials that led the charge in wanting to proceed with a project of this nature. I do want to call attention to the photo of the tree on the right. That is one of the oldest, is it gumbo limbo, Amy? I forgot.
That's a banyan tree.
Oh, I'm sorry, banyan. I keep getting those confused.
Mhm.
Obviously, I don't know much about plants. It is one
But
of
actually, yeah, I was going
it-
to say, fun fact, we tried to get this designated as a champion tree in the state of Florida. We believe it to be the largest banyan in the state. However, it had a fire inside some years ago, and so it was deemed ineligible. But it's massive and it's huge, and it's a lot of fun to walk through.
So in the process of securing the funding for the project, we did apply for a Resilient Florida grant, and initially it was awarded, but because of the timing of the project and the fact that we had already selected a vendor, we were ineligible for that grant. And we can go to the next slide. We spoke about partnerships and really getting the buy-in of the community. The neighborhood association was, by all measures, a key partner in the development of the park. They were a very engaged, very vocal group of residents. Our contractor actually the contractor's name is Muslim. They went above and beyond in delivering the park as designed, and really design was happening thanks to Savino Miller all the way up until the grand opening. They were very engaged and working with the contractors and with the landscape companies to really adjust whatever they needed to and make this happen. Our city planning department, which oversaw most of the design portion, they had a lot of ownership in it just because they came up with the original concept. The city commission and the neighborhood affairs committees, those were key to pushing for the success of this. And interestingly, instead of a critique of the regulatory agencies, I feel a certain sense of gratitude because it was their challenges, their pushing that really made us look at creative ways of addressing the issues with meeting the requirements of the regulatory agencies. Next slide, please. Mentioned permitting. Originally, our intent was to use the retention lake with an overflow that allowed it to collect water and then eventually discharge. Through the permitting process, that was denied. We had to maintain the water on site. So while we are taking a considerable amount of water from the neighborhood, it is limited and we have to handle that on site. Environmental remediation was a huge challenge for us. There was a lot of work done, incredible volumes of soils that were removed, relocated, reshaped, and then encapsulated. And then, of course, through the process, there's a lot of lessons that we as a team learned. One, the contamination was a very complex process that required us to really think outside the box in terms of sequencing of work and how we do things, creating a tree nursery so that we could move trees out of the way while we did the remediation and then bring them back. Obviously, that we never want to handle trees more than once, but in this case, because of the contaminants and because of the effort to remediate, we had to take that into account. Next slide, please. Continuing on that thought, the long-term commitment of maintaining this park. We've created this new ecosystem that we hope is an example to our residents and possibly to other communities of what can be done. In order for it to continue functioning the way it should, we need to maintain that commitment, not only in this park, but in other parts of our city as well. So I think that's a real thing that commitment needs to stay true to our goals. Certain things, obviously, we can't do everything in one shot. So that's where incremental adaptation comes in. There's other things we would like to do that we just couldn't do it at this time. And we'll have to start implementing those other little features as we go. And then communicating our resilience goes throughout the departments of the city, where everyone is now part of the team that looks for ways to improve how we look at our environment. Next slide. And then we are ready for questions and answers.
Excellent. Just an incredible project. I really need to get out there, bring my kids to see it, especially now that I know about this massive banyan on premise. So thank you both so much. A few questions. One is, and I know the park has not been open that long, so this might not be pertinent, but how have you addressed stormwater management to allow active park amenities soon after large flood events? Is that relevant here?
Thankfully, we haven't had an event that was large enough to maximize the capacity of the park. So we haven't seen an event yet where the large area that's encapsulated by that perimeter walkway actually takes the flooding. I'm kind of curious to see how that happens once it does. Hopefully, it won't happen too often. But no, we haven't been able to witness the effect just yet.
As we enter into rainy season. So let's hope that we don't have to meet that challenge yet. How did the bidding process differ potentially from other park projects on the beach? Were there any lessons learned that other communities, other municipalities should consider?
Part of our invitation to bid was a requirement that the bidders have a certain experience with environmental remediation. And that was important to us because anyone that's done environmental remediation knows that if the contractor doesn't keep the proper records, if the documentation is not right, then closing the project is miserable at best. And in the worst of cases, you don't actually do the remediation and you leave some of those contaminants exposed. So it was important for us to really put an emphasis on the experience. We were fortunate that the bidders that responded to us did in fact have that experience, and that the contractor that was awarded the contract had actually done a project for the city before. We were familiar with their work and familiar with their staff. They've actually now gone on to get another contract with the city, so they've done multiple projects now. And they are truly one of the contractors that take on projects as a team member rather than as a contractor. And they are consistently at the table with us trying to solve the problems rather than taking advantage of certain situations.
Obviously, there's so many features in this park that aren't just about drainage and stormwater management, but I'm curious, and a ton of costs I can imagine into just the remediation aspect, but I'm curious of whether you all have been able to sort of isolate the costs or the return on investment of the innovative approaches you used here for stormwater management versus if you had to deal with that stormwater in a more traditional sort of gray, exclusively gray way, or is that just too difficult to sort of isolate just that component to be able to compare?
We are in the process of identifying some of those. There's a lot of overlap in some of these though,
Yeah.
so it makes it difficult. But we have begun the process of trying to identify and isolate stuff like the stormwater versus other elements. It'll take us a little while to gather that data though.
I'm sure. I'm sure. Well, this was an incredible example. I hope to see more like this across the region. So thank you so much, David and Amy. Appreciate this presentation.
Thank you, everyone.
You got it. Thank you.
All right. Next, we are honored to be joined by Walter Rodriguez Meyer, the founding principal of Brooklyn-based firm Local Office Landscape and Urban Design, or Local as it's referred, an adjunct professor at Stanford. Walter has led award-winning projects both here in the US and outside that integrate community, infrastructure, and ecology, including the innovative Geralda Plaza project in Coral Gables. And he has helped to shape national resilience policy across 3 presidential administrations. So welcome, Walter. Thanks for being here.
Hello, everyone. How's my audio?
We can hear you fine. Thank you.
Awesome. Good to see Amy and David present that. It was a very strong presentation. I was on the ULI panel in 2018 with Mayor Gelber, and it was exciting to see, a lot of the projects that we built inform the ULI report, and then to see the follow-up and seeing Miami Beach make space for this kind of thinking. And I think in the future, we'll find that while $45 million was a big expense for a park, it's not just a park, it's stormwater infrastructure that can work at the scale of, a 1,000-year rain event potentially, and eventually reduce the insurance premiums for the adjacent properties, which can be done through a floodplain manager. But excited to present today. I've organized a presentation showing some projects in the Caribbean, projects in Miami, and some future projects being done in the county in coordination with Miami Riverkeeper and the South Florida Water Management District. Next slide. So a lot of the work at the firm is science-led design decision-making. In the case with the tree islands of the Everglades, they're a place that are in amongst a lot of water, a place to study where dryness happens. In the tree islands themselves, they are a place that used to be a society that the Miccosukee and Seminole indigenous tribes lived in the tree islands, and they were their homes. What was known in the indigenous culture was that the midden mounds that made up a lot of the tree islands, old mollusk shells and such, were about 40% void in the soil volume. And let's remember that number, 40% void, as we move forward, because it'll be interlaced into the future presentations. And the reason that's important is this study by Dr. Leonard Cinto and his team that included Tiffany Troxler, who presented earlier from FIU. So this study preceded my redesign of Miracle Mile and Geralda Plaza. So this study took the tree islands of the Everglades and built a new tree island, and then studied the growth of the forests over time. And these tree islands feature this microforest that is interconnected with tree roots because they're very, very tightly planted in clusters. And these tree roots interconnect through that 40% soil volume, that void, and they operate like a large sponge. And this is the first study in the United States that correlated something that was known in indigenous history to with modern evidence-based science. And what Dr. Cinto found was that the groundwater levels during the day would lower, a quarter inch per day, as much as a quarter inch, and as much as a few inches a month. The hotter it got, the more the groundwater would draw down. And this was a phenomenon known as evapotranspiration, which is trees that kind of are natural pumps that pump the groundwater up and then aerate the water into the air. So it's kind of an atmospheric cooling. And so these are kind of natural swamp coolers, these trees. And so the hotter it gets, the more of this pump effect happens and the more of the counter cooling effect starts to impact. And so these tree islands would have been cool bubbles in that microforest that would have been high and dry, and the groundwater would have been lowered within the zone of that tree island. And that bottom section on the bottom right corner, that's an important detail that shows the groundwater and the Everglades around it is being elevated, but within the tree island, it's being drawn down by that evapotranspiration. And so what this introduces as a tool for city making, whether it's Coral Gables, Miami Beach, or Key Biscayne, is that in places where there's elevated groundwater during the October high groundwater season, there was a historic check and balance between the forest canopy and the groundwater. And then the trees would help make it cooler and lower the groundwater. But they wouldn't lower it too much that there was subsidence as an issue, just only the super elevated groundwater during the high groundwater season. So that's sort of the science of it. This is Dr. Cinto's work at FIU. When I started to work on the redesign of Miracle Mile and Giralda Plaza, this was about a year ahead of that work. And it was stewing in our firm of like, how do we design cities to operate like the tree islands of the Everglades, like a big sponge. And so next slide. How you pull that off is, next slide. In the redesign of Miracle Mile, it requires removing the compacted fill that is the city. There's about 3 foot of compacted fill all around Miami that was part of urbanizing that disconnects our trees from the groundwater. And so the goal was to remove a lot of that compacted subsurface and put in a structural soil, in this case, a structural soil specification by Cornell University, which is also 40% void, very similar to the tree islands. And so if downtown Coral Gables could be treated as a tree island, can it also inform a lot of our city making moving forward? This approach can apply to parks, like we saw with Amy's presentation. This approach can apply to streetscapes that are completely plaza and urbanized, like Miracle Mile and Giralda. And just like that park, yes, it's expensive. This was a $27 million investment for Miracle Mile and Giralda Plaza together. But you see the entire corridor is now one contiguous urban forest that's where the tree roots can touch each other, hold each other up in hurricanes. Trees tend to share nutrients and information horizontally to the root system. And that can happen below the paving. You can have paving with truck traffic, and below that you can have tree roots growing under the roadbed and more effectively lower the groundwater because the roots are interconnected. Next slide. Giralda Plaza was different than Miracle Mile. Miracle Mile, the entire roadbed was not able to be porous. We only took the parking lane and the sidewalks. But because we were on one end of the jurisdictional overlay was a state highway, and the other end was a county road, we had this city of Coral Gables in between of Miracle Mile. And so the state and the county required us to maintain a travel lane of asphalt that was conventional. And so we left that alone and then adaptively reused the urban space around that zone. So the parking zones and the sidewalks became more like a garden planting in Miracle Mile. In contrast, Giralda Plaza, 100% of the right-of-way was excavated down and took that tree island soil treatment and turned into Giralda Plaza. So this was where we could really build the nation's first living street. Living street, by definition, is porous paving. It has tree roots growing under the entire roadbed and is one massive groundwater management landscape that is a check and balance between the elevated groundwater during the high season and extreme rains. Now, the other part to this is the cultural stuff. A lot of our work is working in cultural event projects. The sky canvas that you see here is interesting about Giralda Plaza in that every season that you come to Giralda Plaza, it's a different artist. And so there's a procurement process with a curated art selection committee. And with one driver, that it's atmospheric art. Atmospheric art meaning it makes the invisible visible. In this case, it either, it makes shade, sun, or interacts with the wind and makes the invisible wind energy into something visible. And so these are a couple of slides of what that artwork looks like as it engages with nature through the streetscape of Giralda Plaza. Next slide. And this, like I said, the overall budget on this was $27 million to build Giralda and Miracle Mile, and that we had city, state, and county as in coordination for permitting, as well as Durham. But for Durham, they required a 100-year stormwater design, which we designed the conventional system for that. And then upstream of that, we had the porous paving and the living street specification, which is essentially operates as a 3 or 4 foot thick horizontal trench that can infiltrate water at high capacity. And the last thing I'll share was that with the stone paving, very expensive surface, it costs about $50 a square foot to build these systems, but it can be done more affordably with more conventional porous paving, such as porous concrete and asphalt, for about $30 a square foot. Next slide. This next presentation is something that informed the ULI work that we did with Mayor Gelber that led to the Bayshore Park that was presented. This was another city in the Caribbean, Puerto Rico, Mayagüez Parque Litoral. Next slide. And you can see construction on the left. This is pre-construction image on the left and post-construction on the right. What you notice is different is at every outfall, there used to be stormwater pipes. We took the stormwater pipes and decommissioned them upstream and inserted constructed wetlands with primary and secondary treatment of stormwater so that the bay can be protected from the city. And inversely, dunes and a coastal forest were introduced to protect the city from surge from Mayagüez Bay. Next slide. And this project was 2 kilometers and $55 million and about 1,000 feet wide. And you see both living infrastructure and hard infrastructure, a hybrid approach between the seawall and the wetlands and dunes. Next slide. And in the wetlands themselves, we have a lot of black mangrove, saltgrass, oysters, and of course, for managing mosquitoes, we have beneficial bacteria, as well as minnows that are native to the Caribbean that eat mosquito larvae. So there's 0 mosquitoes here. That's never a concern. Next slide. And then we'll talk about the future for last minute here. This is working in the multiple watersheds of the South Florida Water Management District, working with Catalina Moran, as well as Miami-Dade County and this is funded by the EPA, so it's federal government, and executed with Miami Riverkeeper with Rachel Silverstein's team. Next slide. Following a civic science and community-led ideas database, Riverkeeper came up with hundreds of ideas that came from the community, and we tapered them down to a handful that could be built and were feasible. And this was one of the projects out of the C7 watershed in the Little River Canal. We ran multiple vulnerabilities, both rainwater, kind of rain bomb cloudbursts, groundwater, vulnerability, as well as surge, and then economic vulnerability, such as poverty and joblessness. Next slide. And those intersecting vulnerabilities helped us with decision making on where to get the most impact for the public dollar. This is a large pilot project for a new park in one of the lowest lying areas, not on the coast, but in the old Little River zone. But we took a whole landform approach to this, that there were ancient islands that were part of the Everglades when the water was higher in the last ice age melt. And we had some ancient sloughs. These are the transverse Everglades that you see in the blue color arrows. It used to flow through the city and connect and have a pour point at the Little River. And so our goal was to build living streets that extend from the park and work uphill to start to manage that water as it approaches Larchmont Park, and then turn Larchmont Park into a large sponge to be able to handle catastrophic flows. Next slide. And this is the design of Larchmont Park. It handles over 1 million gallons of stormwater. You know, a 100-year storm design can be held 100%, and then anything over that might overflow after polishing. So it has a sustainability mode for water quality and a resiliency mode for water quantity. Next slide. And this shows the hydroflow of how water flows from the neighborhood through these freshwater wetlands and then eventually into the Little River. Next slide. This is a cross section of how the sponge park works. So we excavate down to groundwater and then build up from there with a structural soil, 40% void. And then the last polishing of the water is through a new gabion cages that are filled with freshwater mussels. This is not a saltwater canal. This is inside of the tide gate. So everything here is freshwater and static tide, so not a intertidal. But what we designed for using freshwater mussels, the same way you would do oysters in the saltwater zone, we use freshwater mussels in the freshwater zone to polish the water that the wetlands don't pick up. Next slide. And this is a bird's eye view looking back towards downtown, showing how this services the neighborhood. There's affordable housing campus across the street. So this is helping improve the water quantity flooding events that happen for that campus in one of the lowest lying neighborhoods in the county. Next slide. And showing the entrances following a lot of Miami-Dade County park standards. In my 27-year career, I've had the opportunity to work on a lot of Miami-Dade parks, including the master plan for Oliver Park, which was done over 20 years ago when I was working with WRT in Coral Gables. Next slide. And that wraps up my presentation. Look forward to your questions, and thank you for the time today.
Thank you so much, Walter. All right, so our first question actually was from a prior presentation, but I think we didn't get to it, and I think it applies here. I feel that you've answered this in your presentation, but maybe we just will underscore the point and make sure that everybody sort of understands the basics here. Someone asked, does permeable pavement work well in coastal areas, considering Florida's water table and high tide near shores? So can you just talk a little bit more about that, please?
Yeah, the simple answer is it used to not work well in intertidal zones. And then in the early 2000s, there was a lot of work on pilots that design for coastal environments. And the expertise from that came out of University of New Hampshire. Now, since that time, a lot of coastal communities much lower than Miami Beach and Miami have built using that specification. And one reference for folks to learn from is that in Massachusetts, the city of Provincetown, which is just a couple feet above sea level on sand, much like Miami Beach, has gone 100% porous on its right-of-ways in their historic district. They got funding from the federal government as well as state funding to pull off what the design was to keep the streets dry, but they had historic basements because they have 200-year-old buildings there, and they were able to keep the basements dry by designing the street section to pull water away from the private property through the subgrade design.
Excellent. question about the source of funding for both the Coral Gables projects, Miracle Mile and Plaza, as well as the project that you referenced in Puerto Rico.
Mhm. Puerto Rico was a mix of funding from the governor. It was a three-part client. So it was the governor of Puerto Rico, it was known as Anibal. Then there was the mayor of Mayaguez, and then there was the Central American Games Committee. It was part of the Central American Games, which were hosted in Mayaguez. And for folks that don't know about Central American Games, that is, it's similar to the Olympics, more regional for the Caribbean and Central America, and a feeder event into the Olympics. So it's three-part funding for that one. For Coral Gables is 100% funded by taxpayers in the city of Coral Gables. It was seen as a once-in-generation opportunity to pick a design team. I was the landscape architect who was teamed with Cooper Robertson Partners, the architect. We had a very strong local team, which included Coastal Systems International, who did a lot of the engineering and helped us do some innovative support for that, as well as Rodriguez and Quiroga Architects, and Doug Wood from, I think it's now McKenzie Woods Structural Engineering. But very exciting project with a strong local team that was 100% city funded. And before we did the project, and part of the reason why the funding was so large scale in terms of cost per square foot was that there was a lot of flooding in Miracle Mile before on every single summer rain. Mm-hmm. And then after we did this living street spec, as you know, Miami was swamped by Hurricane Irma, and Miracle Mile was 1 month old and open and functioning. And because of its ability to, withstand the hurricane and stay completely dry, and the businesses open the next day, the New York Times wrote about that event. And so, as the nation's first living street, as well as New Yorker Magazine sent a group down with video to record testimony from the business owners who were on the mile and were able to stay open despite their other shops in other parts of the city that took 6 months to recover. But that one shop being open and the profits from that were able to rebuild out of the other more vulnerable places. And it told the story that this was a business economic imperative, especially for small businesses. And it wasn't just about romantic tree hugging and living streets. It actually is, as we learned from Amy Knowles' presentation in Miami Beach, it's now an economic spine for the project, for that neighborhood. That neighborhood will be drier in Miami Beach, much like Coral Gables is drier after Hurricane Irma.
On that point, I don't think probably most people think about sort of the typology of soil or soil quality, right? Was it challenging to get the city of Coral Gables leadership to invest in this excavation of the structural soil and kind of really helping their leadership to understand the benefits that doing so would have on the outcomes of the project? And how did you go about that?
Yeah, it was a long process, and really a lot of the community outreach was focused on programming the surface and the aesthetics of the surface. They wanted a high performance, system that can really deal with extreme rain events. They didn't want just the 100-year stormwater design, which is required. And we could have done a code project, 100-year storm, and be done. But we had a big budget. And so we can take on other things beyond just aesthetics and beauty, and just beyond tree coverage. All of a sudden now we can do a sponge city approach, this living street approach. Yes, it requires more capital funding, but if you ever compare, hard infrastructure, because this is a hybrid approach, it's hard and living together. Hard infrastructure works great at the 100-year storm design, and Gables design required us to do a hard infrastructure backbone to the project. So you have this hard infrastructure that can handle the 100-year storm design. Where hard infrastructure starts to get limited is on extreme surges with salt water, or in the case with Coral Gables, like cloudbursts, rain events, or rain bombs, is that it's called in the hydrograph of a 24-year stormwater design, you're starting to get these new 1,000-year spikes within for about 15 minutes at a time, right? And then they call those rain bombs. And that's where all that flooding happens that hits Fort Lauderdale. It's not about the 24-hour event. It's about the 15-minute event within the 24-hour event where a lot of the flooding comes from. And so the result is the 100-year stormwater design can handle the base load of a 24-hour, 100-year event, but the natural infrastructure of this massive horizontal, French drain or trench drain, it can handle those 1,000-year peaks for a few minutes at a time. It can't handle 1,000-year for 24 hours, but it can chop the peaks of 15 minutes at a time so that the 100-year gray infrastructure design can handle the base load. So in many ways, it's shifting the stormwater conversation to more in manner of how electric engineers work. Electrical engineers work on base load and peak load on design of power plants. If we treat stormwater that way, you'll see that the most cost-effective way to handle the peaks, the 1,000-year stuff, is going to be natural infrastructure and porous paving. And then the other question comes up about maintenance. And we're engaging a study now with Mayor Lago and the head of sustainability at Coral Gables. It's now been nearly a decade that My Miracle Mile has been functioning. It looks beautiful as if it was from day one. It's highly loved and well maintained, but we wanted to quantify the percentage of capital that's needed on an annual basis for living streets such as this one. The typical number is it's between 1% and 5% of capital is your annual maintenance budget for living streets. We're hoping to learn, if we're in that zone for Coral Gables Miracle Mile. And so we'll be sharing those numbers out in the next year or two once we complete that study.
We're going to have you back to hear about that. One of the things that Tiffany commented on in her intro presentation was the need for this ongoing modeling. So pleased to hear that that's happening. It's crazy to think, and Irma almost 10 years ago. Time flies. So thank you, Walter, for this presentation. Your work is incredibly innovative. I'm so pleased that you're working with other communities in our region to share these best practices and bring this kind of project forward in other communities as well.
Thank you. And congratulations to Andy for delivering on that ULI study, and we have a project that's nationally significant.
Take care, Walter. Thank you. Finally, last but certainly not least, we will move up the coast to Martin County and welcome Amy Eason, Environmental Resource Engineer in the Public Works Department at Martin County, and Jordan Pastorius, who is the Assistant Community Development Manager for Martin County, who are going to co-present on their Ripple project. It's great to have you both. Thank you for joining us.
Thank you. Thank you. Thank you so much. So if you could go ahead and play the video that we provided. Thank you. Oh.
The Ripple Stormwater Eco Art Project, a collaboration between Martin County Community Redevelopment Agency and the Public Works Department, led by environmental artist Lucy Keshevars, is a stunning fusion of creativity and eco-innovation. Reconnecting the Old Palm City neighborhood with the St. Lucie River at 4 distinct sites along Southwest 28th and 29th Streets, this project is born from vibrant community engagement and is part of only a handful of projects across the country to receive grant funding from the National Endowment of the Arts. Ripple uses attractive landscaping and green infrastructure, as well as public art, to reflect the community and environment, transforming over 2 acres into a mesmerizing trail with interactive art, educational installations, and cutting-edge stormwater improvements. Ripple showcases how art and nature unite to enhance water quality and flood management. The project project transforms the stormwater treatment area into an aesthetically pleasing public space poised to become an integral part of community life. Throughout the Ripple project, we've transformed 4 sites into thriving ecosystems that work together to clean our water, reduce flooding, and support local wildlife. From the wetland parcel to the beach parcel, every step of the journey showcases our commitment to creating a healthier environment and sustainable future.
Thank you so much for showing that video. So I'm Amy Eason. I'm the Environmental Resource Engineer at Martin County, and I'm here with Jordan Pasteris, who is the Assistant Community Development Manager. And Ripple is just an amazing project, and it includes a lot of community engagement and a lot of different types of treatment for stormwater. So let's get into the presentation. Awesome, thank you. Next slide. So here at Martin County, we really depend on our environment. We love our environment so much that we have ecotourism where people can really engage with the environment, as well as we have a half-cent sales tax for conservation lands that we are purchasing within our county. Next slide. Our location is north of Palm Beach, so we have to deal with water all the time. We have the Atlantic Ocean, and we also have Lake Okeechobee, and we have challenges through agricultural runoff, residential, commercial, and other urban runoff. And with that runoff, we have to deal with impairments. Next slide. Martin County has a lot of impairments, and that little white spot on the west side of our county is the only area that has no impairments. So we have the St. Lucie River Estuary, where we have to experience a total maximum daily load for total phosphorus, total nitrogen, dissolved oxygen, and biological oxygen demand. For Lake Okeechobee, we have to deal with total phosphorus issues. And then between those two TMDLs, we have an overlapping plan that we have to deal with both of them at the same time. In addition, we have the Loxahatchee River Pollutant Reduction Plan, which is down south, which is a voluntary stakeholder plan where we contribute to projects to reduce nutrients. Next slide. We are also a coastal community, and that star represents the location of the Ripple project. We are exposed to tidal exposure and sea level rise. And that's why it's so important that we have systems in place that treat stormwater and also help with flood protection and the future demands of sea level rise. Continue. Next slide. So a little background on this project. It's located in the Palm City Community Redevelopment Area. It is an area that was platted in 1910. And it had an older system, a system that was before regulations. It consisted of drainage swells and culverts and just an uncontrolled discharge into the St. Lucie River. So part of this project was to provide stormwater capture and water quality improvement, but it also had a great community outreach component of this. We wanted to make sure that it improved environmental education and stewardship. We involved the community with creative placemaking, making sure that the public had places to interact with the environment, and we made sure that it was visible to the community's connection to the river. Next slide, please. This project consists of 4 sites, and these 4 sites primarily were for stormwater treatment, water quality for 62 pounds per year of total nitrogen reduction, 21 pounds per year of total nitrogen reduction, and this is all within a 20-acre drainage basin. So this is about 2 acres, and you can see visually here the different best management practices that we use to provide that treatment train. And also have eco art element and creative placemaking. And again, a lot of community engagement. Next slide, please. So for the first site, it was originally a wetland, and it had a lot of invasive vegetation. So the concept really wanted to utilize that wetland and engage that with the community so they can understand the purpose of that wetland, as well as provide an area that they could walk through and really understand the plants and their functions. Next slide, please. So this is the proposed site, or the finished site. And you can see here where we have taken the vegetation, we created islands to work with it. We actually worked with the elevations within the area and provided native plants within it, as well as the trail and areas for people to rest and look at education. Second slide, please. Next slide. So the second site here was actually an existing parcel that Martin County purchased. We wanted to make that connection from site 1 and have another area where we can do different types of treatment. So here we have swales and bioswales with a dry detention, and then we left a space open for the sewer vacuum system. So this is an existing slide of that parcel. Next slide, please. And this is the end result. And you'll see that with this site, we also have a rain cistern that collects the rainwater as well. Next slide, please. So with site 3, it was an existing wooded area. And here we wanted to provide that wet detention, better treatment for the area. Next slide, please. And here's the result of that. We provided a shelter, and within that shelter, there are art panels with solar lighting. We have a dock, a weather vane there, and it just provides that connection from parcel 2 to parcel 3, and it shows you the different types of treatment that can be done. Next slide, please. And then finally, site 4. This is where we connect into the river. Here we propose dry detention area, an area for people to really engage with the river. Next slide, please. And then you can see here where we had areas where we had low-lying plantings. It provides that zen feel. People come and relax and just really engage with the wildlife here. Next slide, please. So Jordan's going to really explain to you the funding and the community aspect of this project.
Hi, yes, again, my name is Jordan Pastorius. I'm the Assistant Community Development Manager of the 6 community redevelopment areas that we have in Martin County, and I manage this one is Palm City that we'll be discussing. And I'm sure, so I have a question to start off, which I'm sure everyone has experienced this, but it is, have you ever been faced with a challenge that just seemed like an uphill battle, but once you started to get the ball rolling, others started to support you and to push that ball a little bit further and further? And that's exactly what this Ripple project was like for 7 years. Actually, probably a little bit more than that. But one of our biggest hurdles was obviously funding. I'll start off with saying the total cost of the project was $2.265 million. And the CRA we only had, after those 7 years saving up, $804,000. But we were able to leverage some of that, where we had a total grant amount of $461,000 and some buy-in from the county as a whole for about $1 million. To talk about some of the funding sources, Ripple was one of 7 eco art projects in the nation that was awarded a National Endowment of the Arts Our Town grant, and the only one in the country to receive a second one. We received 2 Florida Department of Environmental Protection grants, some Florida Power and Light franchise fees, and Ecosystems Management Team Restoration Division partnered with us as well on this project for $900,000. Next slide, please. As Amy said, community involvement was a huge part of this project to get the buy-in. It's in a residential single-family home neighborhood. We started back in August 2017 to establish and convene project steering committees, which included an artist, Lucy Keshevars, Martin County staff, Palm City Community, the Neighborhood Advisory Committee, engineers, landscape architects, and so on. From about September to November, we did site assessments, pre-project surveys with community members, and planned more community events from December through January. One of those included a potluck dinner, which was actually a pretty big success for that neighborhood. A lot of the neighbors came out, exchanged information, told stories, gained trust throughout the project, as well as another big hit was the creative placemaking workshop that we hosted. They really had the hands-on experience of working with different things. One of them included clay, a little clay project where they had little native clay impressions. Some took them home, and some actually were incorporated into the project on some of the big coquina rock boulder sections. They were placed into those. Next slide, please. Some of the community's input during this process included they wanted to see natural materials, educational components, benefits for wildlife, shade and seating, art elements. They wanted to see a way for them to reflect the character of their community. So a lot of different ideas and things to think about to implement into the project. Next slide. Some of those art elements that Lucy wanted to see, as well as the community she sketched up, which included cap rocks placed for seating, interpretive message board panels, the rainwater cistern, shelters with solar panels to power that cistern, as well as some uplighting, coquina rock and ipe benches along the trail. Next slide. In the two shelters that were built, we also included historic and environmental panels, educational panels up in the roof of those structures. You can see if you walk into those, part of the historic panels included the 1910s plat, which was kind of interesting to see, where there now is a bridge. There used to be a ferry that would connect Palm City to Stewart. There's the old post office, things like that, where they were able to establish their roots in that area. Next slide, please. After the creative placemaking workshop on March 3rd, the design team began working on the conceptual designs, and those concepts, along with a few suggestions, were used to create the construction documents. Next slide, please. More community engagement with Lucy Keshavars. She was very instrumental on this. There were a total of 6 tours conducted throughout the project construction phase alone for the general community. There were 2 IFAS virtual water ambassador program presentations she did with she also did a Native Plant Society, and a couple of classes came from a local elementary school and gave tours to them as well. Next slide, please. And of course, this couldn't have been possible without a lot of community support and buy-in. Some of that included the Martin Arts, Cultural Courthouse, Gallery Exhibit, the Old Palm City Neighborhood Advisory Committee, Community Redevelopment Agency, local library, UF IFAS Extension, the Native Plant Society, Lucy Keshavars, and of course our Board of County Commissioners. Next slide, please. So after construction, we were honored with several awards and recognitions, which some included the Florida Friendly Landscaping Gold Level recognition from IFAS, UF IFAS. We were recognized in the Palmetto magazine, the Florida Native Plant Society Award for Garden of Excellence, which there were actually over 10,000 native plantings throughout the project. Special Recognition Award from the Martin Arts, the Florida Redevelopment Association 2024 Out of the Box recognition, Keep Martin Beautiful 2024 Environmental Stewardship nominee, and we're also in the recognized in the Stewart Magazine December edition of 2024. Next slide, please. Overall, this was an enduring community amenity that was a grassroots project, and everyone from the community, the neighbors, the commissioners, committees, boards, we received everyone's buy-in, and it was a great success. And now it is one of the premier community amenities that they have. Thank you.
Thank you so much, Jordan and Amy. What an interesting project. I'm curious, I think after the fact, you can always, and the community can see just how wonderful these projects are, all the amenities that they bring. But it is definitely unique to try to implement this type of project sort of interspersed right in the middle of our residential neighborhood. Did you guys encounter sort of barriers to resident buy-in at first, or were folks always able to see that long-term vision of what this would mean to be implemented within their neighborhood?
Well, yeah, of course, there's always barriers, right? We encountered several of just people just not understanding what we were trying to do at first.
Yeah.
But once they got involved and started seeing some of the concept drawings, then they could start to picture what it could be in the future. And then not just shoving down their throat some sort of engineer design plan, this is what we're doing, goodbye. They were part of the process all along the way. We made changes with their suggestions, and so that was a huge help.
And there was, I think that during your first or second community meeting, there's a public education as to why they were doing it, a whole education, the nutrients that are in the river, what causes those nutrients, why it was important to Martin County to do these projects, because when you're doing these best management practices and you're in this active basin management action plan, those are tax dollars that go into these projects, but in the end, it's also a compliance. So we have to provide these projects to reduce the nutrients within the river.
Right. I love that. You guys focused a lot on the community benefits outside of the stormwater quality aspect, but at its core, that's what it is, which is really incredible. And I really love the potluck dinner idea. I hadn't heard that before, and I think that's such a cool idea. So I hope some others take from that. Jordan, you started talking about how, when you first start with something like this, getting buy-in, advancing the work feels sort of like pushing the rock up the hill. But once you get going, it gets easier. So now after the project has been successfully implemented and you guys have seen great results, I'm curious if you found it easier, specifically within county government, to begin to sort of mainstream this type of approach as it relates to stormwater quality work.
Actually, yeah, working with our public works department closely, I was actually able to implement another project very similar to this over in another community just north on the north side of Stewart called Rio. And we did this very long linear version of Ripple, is like a bioswale type of thing, with all native plantings and just the kind of the same concept. And that went pretty smoothly.
Yeah, the idea is to, have these lands that the county own, be like high performance places. They're not just the stormwater, it's the community. It provides an element to them. It's just not just plain infrastructure.
Yeah, it's not just a stormwater treatment area. It's almost like a passive park where they can walk their dogs or take a stroll and look at butterflies from the native plants and things like that. It's experiential.
Yeah, I really love the idea of trying to think more in a more innovative way about how to activate, the publicly owned spaces, the land that's owned by the community and by the government. That's excellent. Well, thank you both so much. Really appreciate you coming down to Southeast Florida to share this great insight from Martin County. We're always so keen to learn from others across the state, so just truly appreciate it. With that, I think we are actually a little over time. I do want to wrap things up and close out today's webinar by thanking our speakers and those who joined our workshop for your interest, your participation, as well as the really important work that you all are doing to invest in the resilience of Southeast Florida and beyond. I have mentioned before, as a reminder, we are going to post the recording of this workshop and all of the presentations on the Compact's website in the coming days. And I will be sending you an email distributing the link, so don't worry about that. It will come into your inbox. We also look forward to additional feedback about today's workshop in a very brief survey that we will send to you in the same email. Your feedback really does help us continue to improve the future of these implementation workshops. So I thank you in advance for your participation. Thank you all and have a wonderful afternoon.